Alright, this is Lab 5 by Drew Sheriff. So the purpose of this lab was to model Faraday's law in real life and using GlowScript to show how it works.
Introduction to models and details of experiments. On the left, we got velocity over time of the bar magnet falling through on GlowScript, and on the right, we have the actual rod. Assumptions made were that there's no drag, it's a closed system, and acceleration due to gravity is g. The main fundamental principles in detail are force of gravity is mg, electric force is kqq over r squared, force is dp/dt. Brief preview on the main results. Alright, so the length of the rod was 0.299 meters. The inner width was 0.02 meters. The mass was 0.0025 kilograms. Mu naught was 3.2 from Lab 3. In real life, the time was 1.12 seconds, and the model, it said it was supposed to be 1.26 seconds. The system is the aluminum bar and the bar magnet. Surroundings are everything else. The initial conditions are there's velocity is 0 because it's just being dropped, time is 0, both objects are still, and force of gravity is mg. Alright, so coding details explained in a clear, logical manner. So on the bottom left, we have the constants towards the top. We got the plotting stuff. And then we got the actual values I inputted with the length, width, inner radius, etc. And below that, we have a bunch of stuff that came with the code. So do not edit this section. On the top of the page, we got some segments called this segment. Below that, we have the mass and U naught. Then we got visualizing the bar magnet. And then the bottom right picture, we got these equations for magnetic force and electric force and whatnot. And then as we look towards the bottom, we got a bunch of stuff for the ring due to the falling magnet. And then at the bottom, we just got some values. Similarities and differences between the data and model predictions. In real life, it said it was 1.12 seconds, and the model was 1.26 seconds. Central sources of error are in measuring the length of the tube, measuring the mass, stopwatch, stopping the watch.
Alright, what if the resistivity of the conductor were reduced as close as possible to 0? How would the dynamics of the falling magnet change? It would fall slower because if there's less resistance, that would allow a larger current, and a larger current would allow a larger magnetic field and magnetic force that would resist the bar magnet.
There were holes or slots cut into the tube. How would that affect the ring currents? Well, the bar magnet would just fall right through because it wouldn't be a closed system, and that would affect the ring currents by disrupting them and not allowing a magnetic field to go against the bar magnet.